Today, I'm going to discuss about atom. Atom has three fundamental structures. We have proton, electron, and neutron. The first one is proton. Proton was discovered by Ernest Rutherford in 1919, and he performed his Goldfall experiment. He concluded that the protons exist in a nucleus and has a positive charge. The proton's mass is 1.0078 AMU, and the absolute mass of proton is 1.67 times 10 to the 27 power. And the absolute charge of proton is 1.602 times 10 to the 27 power. So the second one is electron. Electron was discovered by J.J. Thomson in 1897, including the cathode ray experiment. Thomson demonstrated the ratio of mass electric charge of cathode rays. So the cathode rays has a negative charge. The absolute mass of electron is 0.0055 atomic units, and the absolute charge of electron is negative 1.602 times 10 to the 19th power. The third one is neutron. Neutron was discovered by James Chadwick in 1932. Neutrons are located in the nucleus with the proton. The formula of neutron is proton minus electron. One of these examples is the calcium. Calcium has a proton of 40.08 and an electron of 20. So proton minus electron. Proton 40.08. The electron of calcium is 20. So this will be 20.08. The second one that I'm going to discuss is about the composition of particular atom. In composition of particular atom, we have three: the element symbol, the atomic mass, and the atomic number. The atomic number is considered as the number of proton. It is usually indicated on top left, and the atomic mass is considered as the number of electron under the element symbol. One of these examples is helium. Helium has the atomic number of 2, and helium has the atomic number of 4.003.
So today I'm going to discuss writing ionic formulas and naming ionic compounds. So first, ionic compound is composed of a nonmetal and metal. In this periodic table, we only included the essential elements which will be used for this tutorial. So each column has different charges. The first column has a 1 positive charge, and the next column has a 2 positive charge. Remember that the charges should be balanced, and if added, it must be equal to 0. So in this case, aluminum has a charge of 3 positive, while oxygen has a charge of 2 negative. In order to balance this out, we must find the LCM of their charges. So the LCM of 3 and 2 is 6. So we need to make their charges 6 positive and 6 negative. So we'll add another 3 positive in the aluminum and 2 oxygen with 2 negative charges. This will result in 6 positive, and this one will have 6 negative. 6 plus negative 6 is equal to 0, so they are now balanced out. Then count how many atoms you have in each element. Al has 1, 2, so it would be Al2, while oxygen has 1, 2, 3, so that would be O3. Our final answer is Al2O3.
I'm going to show you how to name ionic compounds with transition metals. First, you have to remember that there are 2 types of naming when it comes to ionic compounds with transition metals. The first is the classical name, while the second is the stock system name. So first, for the classical name. There are 2 suffixes for the classical name. First is the OUS, then second is the IC. So you use the suffix OUS if the transition metal has a lower charge. For example, ferrous, which has a charge of 2+. While the other one, the suffix IC, you use it if the transition metal has a charge on the higher scale. For example, like ferric, which has a charge of 3+. Then, the most vital part in naming ionic compounds with transition metals, when it comes to its classical name, is remembering which one of the charges is higher or lower. And I guess if you remember that, if you can identify that, then you can simply know how to name ionic compounds with transition metals in its classical name. Meanwhile, if you want to name the ionic compound using its stock system name, then first you need to find the charge of its transition metal. So let's have an example. For example, let's have copper chloride. So if you want to know the stock system name of copper chloride, you must identify first the charge of copper. So for that, we can have a clue by looking at its chemical formula. So for copper chloride, it can have two possible formulas. Okay. So the first one is this, while the second one is this. So for the first formula, we can see that chlorine and copper both have one molecule, and if we check the chlorine in the periodic table, it only has a -1 charge. So it means that whatever charge copper may have, they canceled each other out. So it could probably be a copper 1 chloride. So if this is a copper 1 chloride, then I guess we could say that the other formula, which has 2 molecules of chlorine, is a copper 2 chloride. So this just means that if we make this short, the charge of the transition metal is the number of the Roman numeral you put beside the transition metal when you turn it into its stock system name.
Hi, so we're going to discuss covalent bonding and naming. So what is covalent bonding? Covalent bonding is a result from chemical bonds resulting from the sharing of valence electrons in an atom. The things involved in covalent bonding are 2 or more nonmetals. Nonmetals are the elements in the right side of the periodic table, separated by these ladder-like figures called the metalloids from the metals. So for example, we have N2O4. We have nitrogen and oxygen. There are 2 nitrogen, so we're going to put a prefix of di. So dinitrogen, plus we have 4 oxygen, so we're going to put a prefix of tetra, plus the root, which is ox plus I. So the final answer is dinitrogen tetraoxide. So what if we're given dinitrogen pentoxide? So we have nitrogen and oxygen. We have a prefix di, so we're going to put 2 in the nitrogen, and pento, which means 5, so we're going to put 5 in the oxygen. So the final answer is N2O5.